Every advanced chip on Earth is printed with light, and every beam of that light, in every EUV machine ever built, bounces off mirrors that exactly one company can make, not ASML. ASML builds the machine around them. The mirrors come from Zeiss, a German optics maker founded in 1846, owned by a foundation, and the quietest monopoly in the entire chip supply chain. This week, Intel started high-volume production on high-NA EUV for the first time, which makes this the perfect week to meet the company underneath that milestone. Start with why these mirrors exist at all. EUV light has a wavelength of 13.5 nanometers, small enough to draw transistor-scale features, and so extreme that ordinary optics are useless. At this wavelength, light is absorbed by everything, by glass, by any lens you could grind, even by air. So an EUV machine cannot use lenses at all. The entire optical path is mirrors, operating in vacuum. And even mirrors barely survive. A polished bare mirror reflects about 1% of EUV light, useless. Zeiss's answer is a coating of up to 100 alternating layers of molybdenum and silicon, each just nanometers thin, tuned so the reflections from every layer add up constructively. That lifts reflectivity to about 70%. 70% sounds good until you remember the projection optics alone bounce the light 6 times, lose 30% per bounce, and most of the source's power never reaches the wafer. That is why every fraction of a percent of reflectivity is worth millions. Now the part that sounds made up. For the image to stay sharp at these wavelengths, each mirror has to be polished beyond anything else humans manufacture. Zeiss's own comparison: blow one of these mirrors up to the size of Germany, and the tallest bump on it, the Zugspitze, so to speak, would rise 0.1 millimeters. A single mirror takes months of grinding, polishing, and measuring, much of it atom by atom with ion beams. A complete EUV optical system stacks 15,000 parts into 1.5 tons of hardware that holds those surfaces in perfect alignment while the machine around it shakes. Even Zeiss's buildings are instruments. For one new production floor in Jena, the company poured 14,600 cubic meters of concrete in a single continuous pour, because a seam in the slab could show up as vibration in the optics. This is not a component business. It is a precision craft project that happens to sit inside a supply chain. Here is the structure that turns craft into a monopoly. Zeiss and ASML have been partners since the early 1990s, and the relationship is exclusive in both directions. ASML buys its lithography optics only from Zeiss. Zeiss's lithography optics go only into ASML machines. When EUV needed a next generation, ASML did not hedge. It bought in. In 2016, it paid €1 billion for 24.9% of Carl Zeiss SMT and committed roughly $760 million more in R&D and capacity funding to make high-NA optics real. The competitors that once mattered walked away years ago. Nikon and Canon both abandoned EUV, leaving one machine maker and one optics maker for the most advanced manufacturing step on Earth. The numbers followed. Zeiss SMT did roughly €1.2 billion of revenue in 2016. Last fiscal year, $5 billion, more than 4 times bigger, with headcount roughly tripled in 7 years to over 9,000 people. And because Zeiss is owned by a foundation, you cannot buy its stock. The closest proxy trades in Amsterdam and owns a quarter of it. High-NA is the current act. To print smaller features, you widen the cone of light the optics can capture, numerical aperture, from 0.33 to 0.55. Zeiss's solution is anamorphic optics, mirrors that magnify differently in X and Y, far larger and heavier than anything EUV used before, inside a tool that costs around $350 million. Intel moved first. The first high-NA machine landed in Oregon in 2024. And this week, on July 15th, came the milestone. Intel confirmed that select layers of Panther Lake, its Core Ultra Series 3, built on Intel 18A, are running High-NA in high-volume production, the first real product of the High-NA era. Samsung took its first production machine at the end of 2025 and is pushing for mass production this year. TSMC is deliberately slower, holding High-NA for around its A16 era in late 2027. The machines are expensive enough that even TSMC counts twice. And demand just changed shape. In ASML's first quarter of 2026, memory customers out-ordered logic for the first time ever, 51% of sales. SK Hynix, Samsung, and Micron are racing EUV into the DRAM layers underneath HBM4, the memory that AI accelerators are starving for, the shortage we covered in our memory video. ASML's CEO says demand will outpace supply for the foreseeable future. Trace that sentence upstream and it lands in Oberkochen. The real ceiling on EUV output is how fast Zeiss can polish mirrors. So Zeiss is building 25,000 square meters of new production space at its headquarters, a new Dove optics plant in Wetzlar, 50% more cleanroom in Rossdorf, a service site in Phoenix for TSMC's American fabs, and last week it opened its first semiconductor innovation center abroad, in Yongin, Korea, next door to SK Hynix and Samsung, so the memory maker's engineers can iterate on Zeiss inspection and repair tools without shipping wafers to Germany. So what could break this? The moat is physics plus 30 years of accumulated craft. You cannot steal it by copying a blueprint. The pressure point is people. In late 2024, Huawei reportedly tried to recruit Zeiss SMT engineers at up to 3 times their salary. Talent is the only door into this fortress, and everyone knows it. The real risks are quieter. Zeiss's fate is welded to a single customer. If ASML's cycle turns, Zeiss turns with it. And China is attempting the whole stack from scratch. Plausible in decades, not in years. Here is the pattern this channel keeps finding. The loudest wars, Intel versus TSMC, logic versus memory, are fought on top of quiet toll booths that win either way. KLA inspects every advanced wafer, Lasertec checks every EUV mask, and every one of those chips is drawn with light that bounced off Zeiss mirrors. Industry analysis, not investment advice. We have already mapped the other quiet monopolies, Lasertec, the only company that can inspect an EUV mask, and KLA, the inspection empire inside every advanced fab. Both are linked below. Subscribe for the actual semiconductor industry view, grounded, even-handed, no hype. Thanks for watching.